Good morning, children. In today's class, we are proceeding to exercise 5.6 Objective type questions in Chapter 5 Two-Dimensional Analytical Geometry 2. Question number 1. The equation of the circle passing through 1, 5 and 4, 1 and touching the y-axis is given, where lambda is equal to. We are given the circle is touching y-axis. If so, from center to y-axis, the radius, I can say this coordinate. We know the center is minus g minus f. So from center to y-axis, because it is touching, it is nothing but the radius. So I can treat it as plus or minus g, depending on the position of the circle. But we know the radius of the circle is root of g square plus f square minus c. Comparing these two, as I square, I try to get cancelling g square, f square equals c. Now we ought to know what is f and c from the equation given. Compare the given equation with the general equation of a circle. X square, y square, 2g will be x coefficient, 2f will be y coefficient and c the constant. Now I need what is f and c to substitute in this relation. So what is f? I can compare y coefficient in both the equations. 2f is y coefficient. In this, near y I have minus 6. Along with y I have lambda and 3. So 3 lambda minus 6 will be 2f value. What is c? The constant. What is the constant here? I have 9. Also minus 19 lambda. So I have 9 minus 19 lambda. Lambda is here, minus 19 is here. Let us substitute this here. F square. What is f from here? Minus 6 plus 3 lambda by 2 the whole square equals. What is c from here? 9 minus 19 lambda. As I square and simplify, 6 square, 3 lambda the whole square minus 2 into 6 into 3 lambda, that is 36 lambda divided by 2 square is 4 equals 9 minus 19 lambda. As I cross multiply, 36 plus 9 lambda square minus 36 lambda equals 4 into 9, 36, 4 into 19 minus 76 lambda. In both the sides, I can cancel 36. Bringing 76 lambda to the left, 9 lambda square minus 36 lambda plus 76 lambda equals 0. Or I get 9 lambda square, 76 lambda minus 36 lambda is 40 lambda equals 0. In both the terms, lambda is common, which I can take out. It is 9 lambda plus 40 equals 0. From here I get either lambda 0 or 9 lambda is minus 40 or lambda is minus 40 by 9. So we get the option 0 minus 40 by 9 and the correct option is A. Question number 2. The eccentricity of the hyperbola whose latus rectum is 8. We know the formula for latus rectum, 2b square by a, that is 8. Conjugate axis is equal to half the distance between the foci. Conjugate axis we call 2B. Half. Distance between the focus is 2AE. From here I get 2B is AE, or squaring 4B square is A square E square. What is my question actually? To find eccentricity of the hyperbola. Eccentricity of the hyperbola is root of 1 plus B square by A square. From this case, what is B square by A square? I can rewrite it as E square by 4. Bringing A square down, bringing 4 down. As I substitute, E equals root of 1 plus, what is B square by A square from here? It is E square by 4. Squaring on both the sides, E square is 1 plus E square by 4. Bringing to the left, E square minus E square by 4 is 1. Taking LCM, it is 4E square minus E square by 4 is 1. Or 3E square equals 4. E square equals 4 by 3. E equals root of 4 by 3, that is 2 by root 3. So the correct option is C. Question number 3. The circle intersects the line at two distinct points. Look at the diagram. This is center, say minus G minus F. The radius root of G square plus F square minus C is bigger than the distance from center to the line. If the line is cutting at two distinct points, obviously from center to the line the distance is less than the radius. As I compare the circle equation with the general equation, 2G is minus 4, 2F is minus 8, C is minus 5. So we have identified G is minus 2, F is minus 4. Center minus G minus F is 2, 4. Radius root of G square plus F square minus C. As we simplify, it reduces to 5. From the diagram, the distance of the line from 2, 4 is obviously less than the radius, that is 5. How to find the distance? We know the formula. 3 into 2 minus 4 into 4 minus m divided by root of square plus square. 3 square plus minus 4 the whole square. This answer is less than 5. The distance can be either positive or negative depending on the position. So we put modulus. As we simplify, it is 6 minus 16 minus m divided by root of 9 plus 16, that is less than 5. As I simplify further, it is minus 10 minus m divided by square root of 25, that is 5, and the modulus is less than 5. We can rewrite it as modulus of 10 plus m is less than 5 5s are 25. Whenever I say modulus is below, we rewrite it as minus 25 less than 10 plus m, which is less than plus 25. Taking 10 to the other side, minus 25 minus 10 less than m less than 25 minus 10. Or if I simplify, minus 35 less than m less than 15. Out of the 4 options, option D is the right option. Question number 4. The length of the diameter of the circle which touches the x-axis at the point 1, 0 and passes through the point 2, 3. As I look at the diagram, this circle touches x-axis at A, say 1, 0. Vertically above, let me mark B so that it will be the diameter. 1, 0 tells me when I mark vertically above, it must be 1, say some other point which I don't know, so mark it as C. And 2, 3 is on the circle. Anywhere I can mark. So let me mark here. We know angle made in a semicircle is 90. So if I join triangle ABC, obviously AB is the diameter. So this is a right angle. So when I declare it to be right angle, I can say triangle ABC is right angled at C. Therefore, the slope M1, M2 I will say minus 1. M1 slope of AC. Substituting in y2 minus y1 by x2 minus x1. 3 minus 0 by 2 minus 1, that is 3. Slope of BC. We can say 3 minus C by 2 minus 1. 3 minus C by 2 minus 1, that is 3 minus C. Substituting in the condition, I get 3 into 3 minus C is minus 1, or 3 minus C equals minus 1 by 3. Bringing C to the other side and 1 by 3 to the left, it is 3 plus 1 by 3. Cross multiplying, 3 3s are 9 plus 1 by 3, or I get 10 by 3. My question is to find the length of the diameter. Looking at the diagram, the length of the diameter is C, isn't it? 0 to C, y value 0 to C. So the length of the diameter is C and 10 by 3 is the right option. Option C is the right choice. Question number 5, the radius of the circle. We know circle should have x square and y square same coefficient. So as I look at the equation, I understand B must be equal to 3. So rewriting the equation, it is 3x square. Wherever B comes, let me put 3. 3y square, 4 into 3, 12x, 6 into 3, 18y, plus B square is 9, that is equal to 0. Comparing with the original equation, I need to divide by 3. So it is x square plus y square plus 4x minus 6y plus 3 equal to 0. As I compare with the general equation, x square plus y square plus 2gx plus 2fy plus c is equal to 0. I get 2g is 4, 2f is minus 6 and c equals 3. From which I get g is 2, f minus 3 and c 3. As we substitute in the radius formula, the question is to find the radius. Root of g square plus f square minus c, that is root 10. So the right option is C. Question number 6. The center of the circle inscribed in a square formed by the lines x square minus 8x minus 12 0, y square minus 14y plus 45 0. As we try to solve the two, we get x is equal to 2 6, y is equal to 5 9. It is also clear from the diagram. X value 2, x value 6, y value 5, y value 9. So as we know, we need to find the center. Center is nothing but midpoint of these two, midpoint of these two. So how do I find it? The center will be x1 plus x2 by 2, y1 plus y2 by 2. The midpoint I can say. Here x1, x2 are 2 and 6, y1, y2 are 5 and 9. So I get 2 plus 6 by 2, 5 plus 9 by 2. So my answer is 4, 7. Out of the 4, option A is the right option. So the circle is inscribed between x is equal to 2, x is equal to 6. The mid value will be 4 for x coordinate. And between y is equal to 5 and y is equal to 9. So the mid value will be 5 plus 9 by 2, that is 7. So the center will be 4, 7. Question number 7. The equation of the normal to the circle which is parallel to the line. Given parallel to the line. So normal will be having same x, same y. Only the constant is changing. Parallel lines change by constant. But we know normal to the circle passes through the center. So from the equation of the circle, which we have compared with the general equation, identify what is G and F. Center minus G minus F is 1, 1. Substituting the center here, it is 2 into 1 plus 4 into 1, that is K. 2 plus 4 gives us K value as 6. Substituting that back, 2x plus 4y equals 6. Dividing by 2, we arrive x plus 2y equals 3. So the correct option is A, where we get x plus 2y equal to 3. Question number 8. If p, x, y be any point on 16x square plus 25y square equals 400 with focus given, we need to find out pf1 plus pf2. Looking at the equation, it is nothing but an ellipse. In an ellipse, P is any point, F1 and F2 are the focus. Then, PF1 plus PF2 is 2A. To find A, recall the equation, we need to have right hand side to be 1. So, divide by 400. I get x square by 25, y square by 16, 400 by 400 is 1. The bigger number we treat as a square, the smaller number as b square. So a square is 25, so a is 5. 2a is my answer. 2 into 5, we arrive at 10. So 10, option number C is the right. Question number 9. The radius of the circle passing through the point 6, 2, two of whose diameters are x plus y equals 6 and x plus 2y equals 4. We know diameters intersect at the center. So solve the two diameters to get the center. As I solve, I just subtract. X minus x cancels. Y minus 2y gives me minus y. 6 minus 4 is 2. So we get y as minus 2. If I know y, put it back in this equation. Y equals 6 minus x, or x equals 6 minus y. So x is equal to 6 minus y value minus 2. So we get x is equal to 8. The center we have found out as 8, minus 2. Call it as O. It is given the circle passing through 6, 2. So call that as A. This is center, this is passing through. So what is the radius? The distance between the center and the passing through point. So OA we call the radius. Find the distance formula. It is 8 minus 6 the whole square plus minus 2 the whole square. As we simplify, it is 2 square, that is 4. 4 square, that is 16. So we get root of 20, which can be further written as 4 into 5. So it is 2 root of 5. 4 square root 2, 5 square root is root 5. So out of the 4 options, the B option is correct. Correct answer, 2 root 5. Area of quadrilateral formed with focus of the hyperbolas x square by a square minus y square by b square equal to 1. The first type of hyperbola. So these are the focus. One focus I call AE, 0. Another focus minus AE, 0. We have the other type of hyperbola x square by a square minus y square by b square equals minus 1. So the hyperbola goes like this. When I have the hyperbola like this way, we have the two focus here. Here b square will be the transverse. So I have 0, BE. The other one 0, minus BE. We are just joining all the 4 focus. So say this is A dash, B dash. When I join, it will look like a quadrilateral. The question is the area of the quadrilateral. How to find the area of the quadrilateral? It is half of diagonal 1 into diagonal 2. As we know, this is x-axis and this is y-axis, which incline at right angles. It automatically reduces like one rhombus. So I can very well say the area is half d1 cross d2. Diagonal 1, the distance is AE plus AE, that is 2AE. The other diagonal is this, BE, here BE. Coordinate is negative, but distance is BE. Together 2BE. For the first hyperbola, we know E equals root of 1 plus B square by A square, or I will say root of A square plus B square by A square. If I cross multiply, A square, square root is A into E. AE equals root of A square plus B square. For the second hyperbola, this is second type. Here I have E equals root of 1 plus. Now this is second pattern. So my formula is A square by B square. If I take LCM, it is root of B square plus A square by B square, square root is B. As I cross multiply, it is B into E, that is root of B square plus A square. Put these answers back in our result. What is area we have derived? It is cancelling 2. I have AE, that is root of A square plus B square. 2 into BE, that is root of B square plus A square. Root and root will get cancelled. So we are just left with 2 times A square plus B square. And the correct option is B. Question number 11. If the normals to the parabola y square equals 4x. So we need to find the normals and then proceed with the other things. Normal is drawn where? At the end point of the latus rectum. So let us find out all these things first. Y square equals 4x is the equation given. Compare. Y square equals 4ax. 4a is 4, so a is 1. So this distance I call a, which is 1. The latus rectum is a line passing through the focus and perpendicular to the axis. And this I will call ends of the latus rectum. One is a comma 2a, another one is a comma minus 2a. A is 1, so I get 1 comma 2, 1 comma minus 2. So we get ends of the latus rectum a comma 2a, a comma minus 2a. Now my question is to find normal at the latus rectum end. First let us find out tangent. How to write tangent for this equation? y1 equals 4. Wherever x comes, x plus x1 by 2. Y square becomes y1. X becomes x plus x1 by 2. The technique of writing a tangent. Wherever x1, y1 comes, we put the end of the latus rectum, say 1 comma 2. As I put 1 for x1, 2 for y1, we simplify. We arrive at the equation x minus y plus 1 equals 0. But my question is normal. How to write normal for this? It is interchanging x and y coefficients. Changing the symbol, changing the constant. So normal will be x plus y plus k equals 0. To find k, again substitute the point 1 comma 2. 1 plus 2 plus k 0, giving us k equals minus 3. Putting k value back in normal equation, we have arrived x plus y minus 3 equals 0. So the first two lines we have derived. From the parabola equation, what is A? Ends of the latus rectum. Tangent at the end and then normal at the end. Now they have given this normal that we have derived is a tangent to the circle. So we have drawn a circle. The center is 3 minus 2. The radius is r. For this circle, this normal becomes a tangent. Whenever I say tangent, center to the tangent, the distance is nothing but radius. R equals the distance formula, say ax1 plus by1 plus c by root of a square plus b square. In this question, a value, here the coefficient is 1. B value, the coefficient is 1, C value minus 3. And x1 is the center, that is 3, and y1 is minus 2. As I substitute, it is 3 minus 2 minus 3 divided by root of a square plus b square, that is 1 plus 1. Squaring, we get r square is minus 2 square is 4. Root will get cancelled. I am just left with 2. So r square is 2. Out of the 4 options, option A is the right choice.